All right, let's get started on our independent practice. So, experimental probability of simple events. Brandon and Kevin play Call of Duty against each other online. This weekend, they played 150 games. Brandon killed Kevin first 21 times. What is the probability that Brandon will kill Kevin first the next time they play? Excuse me. So, first we need to text code. So they played 150 times. Brandon killed Kevin 21 times. What is the probability that Brandon will kill Kevin the next time they play? Okay, so we want the probability. I'm just going to put Brandon, kills Kevin. And so with experimental probability, on top is what we're looking for. So the number of favorable trials, right? So it happened 21 times. And on the bottom goes your total number of trials. So on the bottom, we're going to put 150. Now, we have our probability written as a ratio. They want us to write it as a decimal. But for me, I'm going to go ahead and simplify it first before I turn it into a decimal, or you can just turn it into a decimal right away. Because I know that 150 or 15 is divisible by 3, and so is 21. So if I divide by 3, I know it's 7 over 15 divided by 3 is 5, so 50. So 7 over 50. There's two ways to do it. You can do top in, bottom out, or you can try to get a denominator of 100. So you can use place value. I know that 50 times 2 is 100. So 7 times 2 is going to be my new number up top. Another way is top in, bottom out. So 7.00. So 50 goes into 71 time. 50 subtract, I get 20 or 200. 50 goes into 200 4 times. So either way, in decimal form, so fraction form was 7 over 50, and decimal form is 0.14 because it's in the hundredths place. All right, so the next problem says Jose is polling his friends at lunch about their favorite ice cream flavor. 13 friends said chocolate, 11 friends said vanilla, 12 friends said strawberry, and 9 friends said butter pecan. If Jose and a friend go to the ice cream shop, what is the probability that his friend will order butter pecan? All right, so I need to text code. We have 13 chocolate, 11 vanilla, 12 strawberry, 9 butter pecan. We want the probability that he's going to order butter pecan. So I don't know about y'all, but it's kind of hard for me to read it all in a word problem. So I'm going to write it out. So chocolate, there's 13. 12 said strawberry, 12. 9 said butter pecan. I must have missed one. 11 friends said vanilla. 11. So 13, 11, 12, and then 9 butter pecan. Okay, so I know with probability that I'm always going to put my total on the bottom. So I know I'm going to need my total. So 3 plus 2 is 5, 6. 6 plus 9 is 15. 1, 2, 3, 4. So 45 is my total. And I am looking for the probability of butter pecan. So what I'm looking for, what actually happened, is going to go on top. So the actual number of butter pecan goes on top. So 9 friends with butter pecan. And on the bottom is the total number of trials, or the total number of friends. So 9 over 45 is my probability. And then I'm going to go ahead and make sure I simplify. So 9 and 45, well, 4 plus 5 is 9, so I know it's divisible by 9. So divide it by 9, divide it by 9. 9 divided by 9 is 1. 45 divided by 9 is 5. Okay, next problem. It says for the past 4 weeks, Mike has been recording the daily high temperature during the time the high temperature has been greater than 45 degrees on 20 out of 28 days. What is the experimental probability that the high temperature will be below 45 on the 29th day? Okay, so there's a lot of reading going on. Let's text code so we know it's important. So, does it matter? Okay, high temperature, that's not important. The high temperature has been greater than 45. Oops, it's supposed to circle, sorry. Okay, so greater than 45 on 20 out of 28 days. So I'm going to just go ahead and write it out. So greater than 45 degrees, and it's a probability, and it's happened 20 out of 28 days. Okay, so what is the experimental that the high temperature will be below 45 degrees on the 29th day? Okay, so if 20 days out of 28 days it was above 45, what is the probability that it's below 45? So they gave us the probability, and they're essentially asking for the complement, right? They're asking for how many are not included in this situation. So it's either going to be above or below. And I know some of you may say, well, it could be equal to 45, but in this case, we're just going to focus on either greater than or below 45 degrees. So if you remember back to when we learned complement, we said the probability, so this is greater than 45 degrees, plus its complement is going to equal the total, right? So the total is 28 days. So out of all the 28 days, 20 days it was warmer than 45, so the rest of the days it must have been below 45. So we need a common denominator. We already set it as 28. We set our denominator. So 20 days plus what is 28? So 8 days. So the complement, so I can write it out as the probability of lower than 45 degrees Fahrenheit is equal to 8 out of 28 days. Now, can I leave it like that? No. I have to simplify, right? So I know I can, 8 and 28 are even numbers, can divide by 2. So I get 4 over 14. Can I divide again? Still even numbers, divide by 2, divide by 2. I get 2 over 7. Well, 7's a prime number, so we have our answer. Okay, last one. Eleanor rolls a dice. What is the probability of her not rolling a composite number? Okay, so the probability of not a composite is what I'm looking for. Okay, so not a composite. I went ahead and wrote out 1 through 6 because when we do a dice, we always want to write out 1 through 6. So I'm focused on not a composite, but let's think about what a composite number is. A composite number is a number that is only divisible by 1 and itself. So it can only be divided by 1 and itself. So is 1 a composite number? It can be divided by only 1 or 1. Is 2 a composite number? Well, yes, it can only be divided by 2 or 1. 3, only divisible by 3 or 1. What about 4? Now, 4 is divisible by 2 and 4 and 1. So that is not a composite number. Then I have 5. 5 is only divisible by 1 and 5. And 6 is divisible by 2 and 3. So that's not a composite number. Okay, so I have 1, 2, 3, 4 composite numbers. And then I have not composite. Hi, Avery. Is 2, which are 4 and 6. Okay, just a second. Okay, so 4 of them are composite numbers, 2 of them are not. I'm trying to find the probability of it not composite. So I'm trying to use 4 and 6. So there are 2 out of 6 that are not composite. And of course, we have to make sure that we simplify it. So we can divide by 2, divide by 2. So it's 1 over 3 that are not composite. And it wants us to write our answer in a percent form. So this is one that we should just know, guys, 1 over 3. If you don't, you do top in, bottom out, put a decimal. 3 goes into 10, 3 times 3 is, oops, I don't know why I put 3 down here, 9, subtract, you get 10, and it's a repeating decimal. So 0.3, 3 forever. And then to change it to a percent, Avery, stop. To change it to a percent, you're going to move your decimal 2 places. So it's 33.3%.